So before moving on to async IO, let's discuss about memory management in Python. So in Python, everything is object. Whether you define a function or you define an integer, a string, or whatever data type you choose, everything is object in Python. As you know, we have integer x, let's say, and the value is 10. Now what happens is we have private heap. So on this heap, this 10 will reside. So what happens is there is 10 and a reference will be there to this 10, of which we will use into the variable x. So everything is kind of on the heap with the help of reference. So that's why even if you do x equals to 10 in Python and you print out id of x, you will get a number, a big number. Okay, now think about it. If I do y equals to x, now y is also pointing to x and x is pointing to this 10, so that means x like x, y is also pointing to this 10. So if I do print id of my x, I will get the same number. So this is how referencing is done. Even if I do z equals to y, I will get the same number, correct? id equal to z, I will get the same number because z is pointing to, okay, this is y, sorry, z is pointing to y, y is pointing to x, so all of these numbers are same. So this is one thing, that we have a heap. And if I do z equals y plus 1, that is 11, correct? So what happens is we will have 11 here on the heap, and y and z will be pointing to this 11. So now my id of z will change to some new number that I don't know, that depends. Okay, so if you understand this thing, this is like how the referencing works in Python. So memory management in Python involves private heap containing all Python objects, and data structure. Okay, all the Python objects and data structure resides in private heap. That's it. The allocation, deallocation, segmentation, pre-allocation, caching, all of these things is managed by Python Memory Manager. So Python Memory Manager ensures that the internal management of private heap is working fine, and all of the various dynamic storage management things, for example, like segmenting the memory, for all of these things are done with the help of this Python Memory Manager. So this Python Memory Manager internally uses, like in the C programming we have malloc, etc. So those things are used. It is said that we should not use these functions directly, so that they should not interrupt with basic Python flow. So the Python memory management is divided into two parts. One is heap, on which the Python objects are residing, and one is the stack memory. So stack memory is like where let's say if I define a function def foo of something and return 3. So this function or all of the execution will be on the stack. So we have a stack on which all the local variable we defined x. So x was stored with the help of reference that was on the heap on the stack. So the local variable etc. define all the functions are actually defined in the stack, and the heap, all the objects are defined here. Okay, so the stack is used for local variable function calls. Okay, so every time when we call a new function, a new stack frame is created, and this stack frame contains information like local variable and the pointer for that function. So the stack memory is managed automatically by the Python runtime, and the allocation, deallocation, etc. are made and returned. Okay, they are in the stack itself when the function call are made. So the last thing about this memory management, a small intro, is garbage collection. So there are cycles of garbage collection running, like garbage collection 0, 1, 2. These 3 cycles are there. Purpose of garbage collector is to delete those objects which are not in the use. So there are generation 0 object, which are new objects. Then there is generation 1 garbage collector, that is object that have survived one garbage collection cycle. So survived one garbage collection cycle. Okay, that's have survived 2 garbage collection cycle is the generation 2. So the garbage collector runs periodically, okay, and it collects objects that are no longer reachable. For example, like if they are not having any reference, so it will collect them. So last time we discussed that there is a reference counting thing. So whenever the reference counting reach 0, that means their object is not reachable, and garbage collector will discard or delete them from the memory. Generation 0 objects, which are new objects, are like most frequent, and the generation 2 are like less frequently collected. Okay, so let's make a new file here. So I just want to show you the things that we discussed. So let's say we defined a new variable 10, x equals to 10, y equals to x. If I do print id of x, and if I do print id of y, so as you can see here, we have received same IDs, correct? Now if I do, because both x and y are pointing to the same 10 in the heap memory, okay, so if I do z equals y, now if I print id of z, so I will receive the same thing. Okay, again same thing. Now if I do z equals y plus 1, that is 11, okay, and then I do print z and print id of this z. So let's see what we get. We get a new id now, correct? We get the value that is 11 and the id is different from the above 3. So this is about like how the referencing is there in the case of Python. Okay, so last thing, like we will see like how the reference counting is there by the help of code. So we'll define a class, and we'll see like how many references are there of that particular class. If we do with the integers, right, there are many references of the integer internally also used by the Python. So if you like check the reference, total reference of any integer 10, 11 or something like we do with x equals to 10, so you will see like there are 20, 15 and so like these type of references. But if we make our own class, then like obviously that is our class, so the reference Python will not be using it internally. Okay, let's make this class. It's a color class, and it have red, blue and green, 3 variables, and now we define a object of this color class, and we are checking the referencing by the help of getRefCount of the CLR object that we defined. So you will see like we will get 2 references here. The region is you see we have the ref count of the object as 2, and the region for this is because Python internally also using the reference when we called the object, okay, the CLR object, and one it is like by the memory itself. So that's why we are getting 2. Like let's say if I make new CLR2 equals to CLR, and if I check now what happens, so it should increase. Now the ref count have been increased. Okay, so and now if I delete and then again print, okay, so if I delete the CLR2 and then check the reference, what happens? Now the reference is reduced to 2. Okay, so this is there about the reference checking. So we learned about the Python memory management in this video. We checked like how to get the reference count, how to see the like identity, reference identity by the help of ID, and we checked like how the stack and the heap works. So this is about the memory management in Python. Thank you.